Good afternoon. It is 1 minute after noon, so it's a legitimate comment. Welcome to our forum today. My name is Vera Potapenko. I'm the Chief Human Resource Officer for Berkeley Lab, and I'm also the Diversity Officer for the lab. And today's presentation is a very special event here. But before we get there, I thought I would start with a little quiz, and I suspect that you can respond pretty quickly to this quiz. So when I say diversity, what comes to mind? Colleen?
Different skills.
Okay. John?
Different viewpoints.
Okay. What else? Yes?
Inclusion.
Okay. Different cultures?
Different abilities.
Different abilities? Age? Background? Many ways that we can define diversity. Now let me ask you another one. When I say inclusion, what comes to mind, Bill? What comes to mind when I say inclusion? Everybody? What else?
Fairness.
Fairness?
Understanding differences.
Understanding differences? One more, yes, please.
Listening to what many different people have to say.
Listening to what many people have to say in their perspectives. Well, you're of course all right. There are many opinions on these two words of diversity and inclusion. And frankly, the Diversity Council here at the lab, which by the way is represented has a representative of every single division here at the lab, both on the science side and the operations side. And if you don't know who your member is, call me and I'll tell you. Because they play a very important role in what the work is that we're trying to do in this area of diversity and inclusion. And the main reason that we're so focused on this area is that we believe that diversity and inclusion can actually help us achieve the laboratory mission. On the science side, you know, we talk about team science, which has to do with multidisciplinary collaborations. And on the operations side, we also are very focused on collaborating with our scientists and our technicians in order to support them in achieving the scientific missions that we have. So collaboration is a critical competence here at the lab. And yet when I say collaboration, it assumes certain things like trust, like openness, like listening to each other's perspectives and valuing those perspectives. The Diversity Council, about a year ago, decided that we really needed a more public forum to talk about these topics. And so we established this speaker series to bring noted experts in the area to come and talk to us, and in a public forum to discuss these issues of diversity and inclusion. I also wanted to share with you some principles that the Diversity Council has recently endorsed. And I'm going to read you this document because it's very brief, but I think it captures where the Diversity Council is coming from. These are the principles. Just as science reveals nature's diversity, science organizations reveal their own nature by the diversity and inclusion that they foster. At Lawrence Berkeley National Laboratory, diversity of people and thought is part of our unique social fabric and a key to our research success. It is also a daily and personal commitment and an expectation. Each employee has a role to play. Every employee has a responsibility to act. We believe in the laboratory's mission to share the benefits of scientific discovery with the world. We also respect the differences in our workplace community. In doing so, our actions are guided by the following three principles. Listen to others and encourage collaboration. We are stronger as a group when our uniquenesses are valued. Reach out if you see someone confused or in need. We are concerned about others. Treat others with respect. We believe in fairness for all. I believe that many of your definitions of diversity and inclusion are included in our principles. So with that, I would like to introduce the introducer of our speaker, who is co-leader of our Speakers and Activities Committee of the Diversity Council, Sheila Dixon, who is the Senior Resource Analyst for Physical Bioscience Division. Sheila?
Hello, hello. I would like to welcome you all to our 6th Diversity Speaker Series. To date, we've had speakers such as Michael Hingston come and speak to us regarding surviving 9/11 in the World Trade Center, diversity and adversity. We've heard from Lee Manoir, who spoke to us about unlearning stereotypes, initiating diversity conversations in the workplace. Erna Gross spoke to us about using unique talents and perspectives to craft tomorrow's world. And Yami Ron recently spoke to us regarding inclusion and independence. Today, the Diversity Council is so excited to have Scott Page here to speak to us regarding why teams work, the power of perspective in collaborations. Scott is the author of the book, The Difference: How the Power of Diversity Creates Better Groups, Firms, Schools, and Society. So I would like to introduce to you Scott Page, who's diverse in all that he does.
Thanks. It's really great to be here, and it's also nice to see such a great turnout. I'm violating a rule that we have at the University of Michigan, which is we only come to the Bay Area in the winter, usually. But so I'm getting a lot of heat at home for coming. What I'm going to talk about is 2 books that I've written. One is called The Difference, and another is a new book called Diversity and Complexity. I was introduced a couple days ago by someone who said, these are airplane books if you're going to New Zealand and have a calculator, which is sort of taking it on the chin. What I want to do is I want to do really just 3 things. I want to talk a little bit about cognitive diversity, where it comes from, how I think about it. Then I want to talk about how I think cognitive diversity plays out in specific domains. And I'll take 2. One will be prediction and one will be problem solving. And I'll close with some quick comments on collaboration. Just as background, I'm not a traditional diversity kind of person. My background training was in game theory and mathematics. I have a master's degree in mathematics and a PhD in mathematical economics and business from Northwestern. And originally I was just down the street, the long street, the 101. I was at Caltech as a mathematical economist. And I got interested in complex systems. And I got interested in ecosystems, political systems, financial systems, economic systems. And in looking at that, I got interested in sort of the role that diversity plays in those systems. And so what I'm going to present to you today is just really my mathematical thinking about how these things work. To frame this a little bit, and why I think this is important, is I want to talk a little bit about the changing nature of work. As an economist, when we think about work up until about 100 years ago, it consisted of sort of individual people doing individual tasks. And in that domain, it made sense to think of an individual person having talent and collective talent really being the sum of those talents. So if you're hiring people to pound in spikes, right? Somebody can pound 10 spikes a day, somebody can pound 100. If I want to ask how many of those 2 can do together, I'm going to just sum their abilities. Right? I mean 100 from one and 10 from the other. So it's what we think of as economists an additive world. Right? Well, things changed and we started moving into sort of a world where we make things like the Saturn V rocket, right, with 300,000 components and 2 million parts. And this is sort of the world of specialization of labor and diminishing marginal returns of type. And in those sort of domains, you get that there's benefits of diversity, but it's diversity really by sort of job classification. Well, as many people have written about, we've now moved into what people call the cognitive economy, and it no longer consists of sort of specialized labor working on things, but it's teams of people working on problems. So this is a picture of Google. If you go visit Google, which I have a couple times, you have to sign this long waiver saying that you won't say anything that you learned or saw at Google, but they will let you sit in the boat. It's about the only thing that will happen. To just give a little bit of spin on this, right, the first, if we take something like physics, right, the first 15 Nobel Prizes in physics went to 19 people. Some people argue that it would have gone to 17, but they didn't want to give Mary Curie one alone, so they grouped some guys in there with her. I don't know to what extent that's true, but if you look at the last 15 Nobel Prizes in physics, they went to 41 people. Now, the limit here is 3, and typically when they give it to 3, there's like 5 other people who got jobbed, right, who could have won it, right, but they didn't win it. So why is this the case? The reason this is the case, the reason Nobel Prizes are going to 3, and the reason why if you go to sort of any sort of modern cognitive place, whether it's a university or yesterday I was down at Yahoo, you see lots of whiteboards, lots of open spaces, lots of people working in groups, it's the 41. It's because teams beat individuals. James Gleick wrote a piece a while back saying, where have all the geniuses gone? It used to be 100 years ago, there are all these great individual scientists we talked about, and now we don't. And he basically comes to the conclusion it's because individual scientists are getting their butts kicked by teams of scientists, right? And so therefore, it's just not as fun to write about a team of scientists, or it's just more complicated than it is to talk about Pasteur or Newton or Leibniz. So where I come at this, and I come at this as an economist and as someone who's really, the thing that I like to do is I like to write mathematical models, and I like to sort of understand how the world works through models, and to sort of, in some sense, speak mathematics to metaphor. And so in the world of economics and in the world of business in particular, a lot of things are driven by these proverbs, like two heads are better than one, right? But there's a problem, and there's a great web page for this. There's a great web page for everything. There's an opposite proverbs web page, like he who hesitates is lost, a stitch in time saves 9, right? Well, the same is true with this two heads are better than one, right? You have two heads are better than one, and you have somebody else saying too many cooks spoil the broth. Well, how do we adjudicate between those two things? Well, this is why we do science, right? It's why we don't just sort of have mantras that we just sort of spout, whichever seems reasonable. And so to understand whether two heads are better than one, what I want to do is like sort of, in some sense, do math, right? But how do I do that? Well, so here's the problem. When we think about intelligence, so I have two boys, and like I think most people, I do this weird cultural thing where I like mar my house by marking their heights, right, as they get taller on the inside door jamb. I don't do this. I don't measure their heads. I don't say Cooper's head is 18 centimeters. Look out, Berkeley, here he comes, right? And it's not, because it seems crazy, right, to take something as complicated as a human being and to summarize it in a particular number. So let me go back to the spike example, right? So I think of people working here in material science or working in a physics lab or something, and I have two people. One has an IQ of 120 and one has an IQ of 110. I can't say, to say how good are they as a team, I can't add up those IQs. I can't say it's 120 plus 110, because then I've got somebody smarter than Einstein. And if I just added in somebody with an IQ of 60, I could do amazing things, right? String theory would be done by lunchtime. So I can't add these things up, but I also can't just take the max, right? Because it seems fairly clear that the 110 person might add something to the 120 person. So how do you think about this? So when I got to thinking about this, I realized other people have thought about this. So I went and talked to people who had thought about this, and they're called psychologists, it turns out. And they said, look, here's how you should think about intelligence. You should think about people as having tools. What happens over your life, you accumulate ways of thinking. Ways of representing problems, ways of thinking about problems, rules of thumb that you follow, that sort of thing, right? So formally, the categories I'll use today for thinking about the tools we have is one will be just categories. And this is sort of something that's very well established in psychology, that we sort of create boxes or nouns, if you will, for how we think about the world. So you can think of categories as the nouns you use. And as you become more of an expert in a field, you use finer and finer nouns, right? So before I moved to I'm from the state of Michigan, but before I sort of moved to Ann Arbor, which is really part of car culture, I would distinguish between like cars and trucks, right? Now I think of sedans and coupes and everything else, right? I have more nouns for cars than I care to have. With those nouns, we create sort of causal and predictive models. And these are the stories we have, right, and the models we have for how the world works. We also have something I want to call perspectives or representations. When we really sit down as scientists and try and solve problems, we have formal encodings or representations of those problems. So for example, in mathematics, we might use Cartesian coordinates with x and y, or you might use polar coordinates where we've got a radius, right, and we've got some sort of angle theta. So we've got different ways of representing the problems. If you're a computer scientist, we have binary encoding and gray encoding, right? Two different ways to write things in zeros and ones. As my younger son said, isn't one way of writing things in zeros and ones enough? And I said, no, actually, no, it's not. And then the last thing we have is heuristics. And heuristics, broadly construed, are simple things that people use to try and innovate, like do the opposite. And they're also things like, Newton's method, right? So they can be very, scientific based, or they can be sort of, simple little rules of thumb. So when we think about what makes the 120 person plus the 110 person better than just the 120 person, at the end of the day, it's got to, in some sense, be differences inside their heads, right? So it's got to be that they've got different sets of tools inside their heads. And so if you want to ask why this amazing set of productivity from teams, at the end of the day, it has to come from cognitive diversity. Now, when people talk about diversity, though, they typically talk about identity diversity. They talk about things like race, gender, culture, that sort of thing. So if you talk to psychologists, and if you look at the psychological literature on this, and you ask, okay, where does cognitive diversity come from? It turns out that, well, it comes from experience. If we have different experiences, since our brains filter our experiences and structure themselves, if we have different experiences, we have different brains, right? If we have different training, our brains organize themselves differently. If we have different preferences, we organize ourselves differently, right? And if we have different identities, we organize our brains differently, not because there's some sort of genetic difference. So one thing I talk to high schools sometimes, just for fun, it's like to touch the third rail, is to go with a deck of math slides and talk to 2,000 high school kids, right? Like frightening as hell, right? So I'll do that. I'll sometimes put up a slide of ketchup, and I'll say, you know, how many of you keep ketchup in the refrigerator, right? And some will. And I'll say, how many keep it in the cupboard, right? And some will. And then I'll put up DNA, and I'll say, here's the gene for that, right? And then I'll start laughing, right? They'll know that can't be true, but yet we often make those sort of mistakes, right? We see some sort of behavior and we ascribe to it some essential difference. In reality, most of the differences that are out there, even cultural differences, are not genetic, right? They're sort of accumulated through culture. So let me explain why identity diversity and cognitive diversity are linked, and I'll do this in a scientific context. So around the turn of the century, some cattle in Wisconsin were dying. You'll notice I have a cattle fetish. I used to own cattle, so just let it go. So these cattle are dying. This guy, this Swedish farmer named Carlson, brings in a calf to the Wisconsin Agricultural Research Center. I only know this story because I used to live next door to the Wisconsin Agricultural Research Center. And this guy, Arthur Link, pumps out the cow's stomach, and he finds there's clover in there that's rotting. And it's rotting into something that is known as dicumarol. And this dicumarol is thinning the calf's blood, and that's wiping out the calf. Link then goes and spends some time on vacation at the sanitarium, and then he comes back after 10 years, and he's like got this epiphany. He's like, oh my gosh, we have a blood thinner, right? So he said, we have a natural blood thinner. And since he's got a blood thinner, here's where culture comes in, identity comes in. He works in an agricultural research center. If we can thin blood, you know what we can do? We can kill rats. And that's exactly what they do with dicumarol for a long time, until someone during one of our wars, I think it was World War II, isn't having a very good time. I guess maybe the Korean War. And so he decides to kill himself with the rat poison. But if you drink enough rat poison, enough of dicumarol to kill a rat, what that's going to do for a human is it's going to make you live longer, right? And in fact, next to dicumarol is more commonly known as Coumadin, right, which is a blood thinner which prevents clotting. And next to penicillin has saved more lives than any drug, right? But the interesting thing here is for 20 years, Coumadin sat on the shelf. Well, it didn't sit on the shelf. It sat on the farm killing rats because there were cultural blinders, right? So what you want to think of is whenever any sort of thing you experience, it's going to be reflected and refracted through your culture or your identity. Okay, so let's go to sort of specific tasks. Let's start with talk about prediction. And just to sort of set the stage, another cow. A friend of mine, Jim Serwicki, wrote this book called The Wisdom of Crowds. And in it, he begins with this famous experiment by Francis Galton. And Galton talks about the 1906 West of England Fat Stock and Poultry Exhibition. There's 787 people, and they guess the weight of the steer. Average guess is 1,197 pounds. The actual weight of the steer is 1,198 pounds. So they're within a pound. Now, you could infer from this, oh my gosh, we should let people predict everything, right? But we wouldn't want people predicting the design, which design is best for a nuclear collider or something, right? So there's limits as to when this is going to work. So we want to understand, how does it work, right? Well, there's a long history of prediction going back to the Greeks, right? When the Greeks wanted to predict something, they just went to an oracle, and it told them the answer, right? So they'd go to Delphi, there'd be a woman on a three-legged stool, and she would say, you know, here's what you do. And there's a wonderful book by David Earl called The Future of Everything, where he goes through the history of how we predict. And he's got this long list of rolling die crystal balls. I'm sure you guys do a lot of this stuff here up on the Hill. Animal entrails. I think I saw some earlier. Flights of birds, smoke and fire, neighing of horses. And now we do this thing called modeling. So it could be, look, 20 years from now, somebody could be up here and modeling could look just like neighing of horses, right? But for the moment, we tend to think this is sort of categorically better, right, than all the other stuff. So how do we model, and how do we make predictive models? The way we do it is we create, at least according to psychologists and philosophers of science, is we create categories. We create these nouns. And so the categories, basically, when we see anything, we break it into bins. So I'm going to do this in two different ways. So one way is if I mention like the state of West Virginia, my wife is a political scientist, so what she would do is she would say, oh, West Virginia, that breaks into 3 congressional districts. And she would start talking about how these congressional districts voted in presidential elections and who they elected and things like that. And at some point, I would say, okay, stop, right? So one time I was at the hotel in Chicago, the Family Hotel in Chicago, Palmer House Hotel in Chicago, and I asked somebody there, I said, you ever been to West Virginia? And I said, yeah. And I said, what do you think of it? He goes, well, it's really interesting. If you get a hot dog in West Virginia, there's a big slaw region down in the south, and then there's a little no slaw finger up in the top, right? Now, the reason I bring this up is this seems like fun, and it is fun, and it's so fun that anthropologists get to do this for a living. So one thing that anthropologists do is they use this model called the cultural consensus model, and they go out and they basically ask people, what categories do you use? So I'm going to talk about some work by a guy named Jeffrey Johnson, who now works for the U.S. Army. Jeffrey went out and he wanted to see sort of how do people categorize food. So he went to this cultural, sort of this really interesting cultural group known as People from St. Louis. And he said, here's some, hey, people from St. Louis, he randomly selected some, here's some food items, sort them. And then based on how people sort these items, you can infer all sorts of things about them. So the group that I would be placed in is a group that they call, probably you, many of you as well, it's called the Bobos, which are bourgeois bohemians. And the bourgeois bohemian sort here is fresh fruits and vegetables here, fresh meat and fish here, and then canned things that Michael Pollan won't let us eat, right over on the right. I didn't grow up a Bobo. I grew up in rural Michigan, and my goal in life was to own an Airstream trailer. And the Airstream trailer sort of these same things are things that we know are vegetables, anything that we know is a meat or fish, and then things over here like pasole and sea bass, and whatever this is, fennel, right? I'd have no idea what it is. This would go in the weird stuff I don't want to touch category, right? What's interesting about this, the reason Jeffrey did this is, what's interesting about this is you can actually tell someone's income from this particular sort very well. If the fresh salmon and the canned salmon are in different categories, you're high income. And if they're in the same category, you're low income, right? So who you are affects how you make predictions. Now in science, the same sort of thing plays out. So let's go back to the cow thing, but instead of thinking about guessing the weight of a cow, let's think about guessing the surface area of a cow. So suppose I said, why would you want to do that? It says, how much leather can you get from a cow? This is an important scientific question, right? If you're going to make shoes or something. So how much leather can you get from a cow? Well, this is pretty easy. You just take sort of the surface area integral of a cow. And you open up your calc book and look for the cow function in the back, right? But it's probably not there. So there's a famous, well, reasonably famous book, it's famous to me, I plug it all the time, called The Spherical Cow, which talks about modeling. And the idea is there is no second integral for it. There's no surface area for a cow function. So what you do is you just imagine a spherical cow, right? So think of if the cow were a sphere, how big would the cow be? And then you make some prediction that way. That's great, but there's going to be probably some sort of bias in there. And I'm from Michigan, and our governor, Rick Snyder, used to work for Gateway. You could also make a gateway cow, right? You think about constructing a cow out of gateway boxes and figuring out the surface area that way. Now what's important here, and here's where we're going to get to the sort of ugly math, if we're making a prediction, combining these two, the spherical cow and the gateway cow, is going to be better than using either one of the two. Why is that? Well, you can prove sort of an ugly theorem. And this is a good theorem. 3 different people got tenure off this theorem, so that's good, right? An economist, a computer scientist, and a statistician. So it's a good thing. And this theorem basically says the following. If I've got a bunch of people, whether they're guessing the weight of a steer or doing anything else, the crowd's error equals the average error of the people in the crowd minus their diversity. So translating, what this means is that the ability of a crowd to predict depends sort of in equal measure on the ability of the people in it, that's their average error, and their diversity. So cognitive diversity really, in the predictive context, matters just as much, right, as ability. So if you go to Dalton's steer example, right, the crowd was off by a pound. These errors are squared. So this means on average people are off by about 55, 56 pounds. That's about right? Because steers weigh like 5 times as much as people. We can guess the weight of a person within about 10 pounds. You can guess the weight of a steer within about 50 pounds. So you've got like reasonably smart people, right, who happen to be diverse. Now why they looked at the cow in diverse ways? Let it go, right? Let it go. But they did, and because they did, the crowd was really accurate. So if you take books like Sarah Wickie's book or any of these books that talk about crowds being really effective at predicting things, and you plug this you almost always see this phenomenon. Reasonably smart people, right, that happen to be diverse. The reason you always find it is you wouldn't write a book if it was an obvious thing to predict. Like how many eggs in a dozen eggs, right? Everybody guesses 12. Wouldn't be, wow, the crowd got it right, right? It's only interesting if the crowd gets it right and you think they couldn't get it right, that no one would know it, right? And so what happens in all the cases then is you get most people are close to accurate and for some reason they happen to be diverse. Now this, okay, cattle are fine, but let's talk about important things like movies. Netflix had this prize a few years ago. I'll just zip ahead. In 2006, that's 5 years ago, Netflix has this thing called Cinemax. How many have Netflix or know what Netflix is? Get some. Okay, so Netflix is a place where you can rent movies over the web. And you, what you can do is they have this thing called Cinemax. What's nice about it is like you can look at a movie and it'll tell you whether you're going to like it, right? And so they decided, let's see if the machine learning people and the computer science people can be better than we are at picking what people like. If anybody can beat what we're doing by 10%, we'll give you $1 million, okay? So this, people have real skin in this game. Just for some quick data, movies are ranked from 1 to 5 stars. There were 6 years of data, 500,000 people, 18,000 movies. You know, it's following standard practice, they broke the data into a training set and a testing set. The training set, so this is you sort of train your data on this, and this is what they used to decide who the winner is. The training set, they had a thing you could go probe on your own, and then they had a quiz thing, and they had a final testing set. So they really broke it into 3 sets. Just some asides. Lost in Translation and the Royal Tenenbaums had the widest variance. So this means these were the strangest movies out of all 18,000. So that's a good gut check that that's probably right. Shawshank Redemption was the best movie. It is a very good movie. If you like Morgan Freeman, it's a great movie. And Miss Congeniality had the most ratings. And again, who knows why. Okay, so as teams tried to make sense of this data, they all fairly quickly settled on a similar technique, which builds from that sort of pile sort idea. Which they did is they broke movies and they represented them by a vector. So some of the original models were content-based. So property 1, P1 would be, is it a comedy or is it a drama? Property 2 might be, do people die? Right? Property 3 might be, do people kiss? Property 4 might be, is there a car chase? Right? Property 5 might be, does somebody kiss in a car chase? Right? So they could do all sorts of stuff like that. People are then represented by vectors, and if you like people dying, then you have a positive thing on that, and if you don't like people dying, you have a negative thing on that, right, in the movie. And then your rating is just sort of the product of the movie's attributes plus yours, plus a movie-specific thing and a person-specific thing. Okay, so the initial leader was Bellcore, which was otherwise used to be known as Bell Labs, right? So these are, really, big-time scientists, not goofing around. And their model had 50 dimensions. Now, their best model was 6.8% better. But when they combined their models, because remember we have this theorem that says if you combine models, you're going to do better predicting, right? So their very best model was 6.8, but they had a bunch of models around 6.8. So when they combined them, they got to 8.4, okay? So this 1.6% difference is the diversity bonus, right? What's really interesting about this is eventually, attributes of the movie, things like do people die, do people kiss, turned out to not matter as much as things like how many days between when it was released or not. And so it turns out people like older movies more, and the reason why is people only go back and look at older movies they think they're really going to like. So it turned out to be things about ratings that mattered actually more than attributes of the movie. And there's a nice paper on this by Malcolm Slaney from Yahoo. Okay. Now, the reason that more models work better than one, right, is again this sort of averaging thing. But here's the interesting thing. So Bellcore has this lead. They're at 8.4%, 8.5%. And eventually Ron Bell, who he's fun to have out to give a talk about this. He's just a great guy. Ron's boss comes up to him and says, Ron, it's great you're winning the Netflix prize, but you have a thing called a job. And you should probably go back to your job. But Ron's a brilliant statistician, so he knows this. So what does he do? He calls up the team in second and third place and says, look, we're not winning. We should probably all get back to work, so let's merge. So they form a new team called Belcore's Pragmatic Chaos, which is a 7-person team. Now, it's functionally diverse. It's got machine learning people from Bell Labs. It's got straight statisticians, computer scientists. They're from all over the globe. They now have 800 variables on these movies, which is too many to put in single models, so they're just sort of averaging them. Well, what's interesting is now their best model, when they steal ideas from one another, their best model gets to 8.4%. But when they average all their models that they've got, they get to 10.1%, so they win. So they pop up in the champagne, they win, but then it turns out once somebody breaks 10%, the contest ends in 30 days. Now this thing's gone on for almost a year, but the rules were that once somebody breaks it by 10%, there's 30 days more. And the reason for this is they were afraid like some undergrad for Berkeley would beat it by 12% in the first hour. Right? No, I mean, right, that could have happened. So now let's think. You've got the 3 best teams that are above 10%, and you've got 23 other teams that aren't even close. But they're not as smart, but what do they have going for them? There's 23 of them, and they're diverse. So what do? These 23 teams are from 30 countries. They just merge. They just create a common website. They call themselves the Ensemble, and they merge. And there's nice articles in the Times and in Slate. I won't bother reading them. But here's where it gets interesting. The winner is, they submit these things. This is the error. This isn't the improvement. So the Ensemble's error is 856,714. Bellcore's error is 856,704. Bellcore beats them. Barely. Right? But the Ensemble had so much diversity, they even had someone who read the rules. And the rules were that it only goes to 4 decimal points. Which is great. And so then the rules go, who submitted first? And luckily Belcore, and here's Ron on the side. He's a great guy. Because Ron, when he put the group together, he said, we'll give all the money to schools in New Jersey, the public schools in New Jersey. So everybody was rooting. I was certainly rooting for Ron. And so Belcore ended up winning by 22 minutes. So here's what's interesting now. Let's just think this through for a second. Now we've got 2 models that are equally good, that are different. So what has to be true? Average them, you're better. So if you go to the Ensemble's webpage, after this whole thing is over, they have this. Oh, by the way, here's what Bellcore beat them by. Here's what we beat them by. If you just average our 2 models, you beat them by 10.2. Right? So here's a really fun, I mean, if you think as a mathematician, it's just that the act of predicting is convex. So there's also some simple convex function theorem. It's really just some Jensen's inequality on steroids in a way, right? You're just getting at the, so the average of 2 things equally good is going to be better. But what's funny is this runs counter to how we think, right? What it's really telling us is if we're trying to sort of look around the bend of the curve to see what's going to happen, it's really valuable to have people who think differently. Now there's a trade-off here though, right? If someone who thinks differently but they're not very accurate, then it's probably not worth bringing them into the mix. But if they're close to as accurate and they think substantially differently than you do, right, it's probably worth bringing them into the mix. Right? Because we see here the 23 teams who weren't close, right, to Bellcore, when they combined, they were able to tie them. Okay, so let's move to, that's prediction. Let's move to innovation. So innovation is something that's been studied to death. Here's one of the most recent books on innovation by a guy named Stephen Johnson, which is particularly good. If you pick up any one of these books, it'll have like a bunch of really cool buzzwords about what drives innovation that you don't know what they mean by looking at the words, which is good. That's why they have to buy the book. But if you look at the adjacent possible, let me just take up, like the adjacent possible in Stephen's book is if I'm sitting at a solution, what are the other things I can think of? Right? So what is adjacent to it? What is possibly adjacent I can possibly think of? Error is just making mistakes. Acceptation is taking an idea from one context and applying it to something else. All of these ideas, with the exception of platforms, which is basically a fancy way of saying like create something like the iPod so people can innovate on top of it, are really about diversity. They're about some sort of new idea coming in, right, and allowing the collection to do better. To see the micro foundations of how this works, I want to go back to sort of this simple idea of sort of IQ test, measuring people's head size. So when they give IQ tests, they ask sort of, they're seeing what heuristics do you know, or what heuristics can you construct on the fly, or what sort of representations do you know, and what representations can you construct on the fly, for at least one class of these sort of general purpose intelligence tests. So they'll give you questions like this. This is a 1, 2, 3, 5, blank 13. And the answer to this one is 8, right? I hope. There it is. And you can do this either 1 plus 2 is 3, 2 plus 3 is 5, or you can subtract. You can do 13 minus 8 is 5, 8 minus 5 is 3, 3 minus 2 is 1. When they give these tests, they typically start with this one, right, which is an easy one, just so you can sort of see what the game is, right? So it's like 1, 4, 9, 16, blank 36. It's 25, and that's fine, right? Then they start giving you ones that look like this, right? One of my friends saw this, and he goes, this is easy. These are the years that Boston won the pennant, which was just great. He loved that line. Just as a quick aside, I gave this in front of, almost every economist at the IMF right before the financial markets fell apart, and nobody got it. And they gave it at a middle school in Detroit the next day, and 2 kids got it. So in the long run, your money's good. Short run, you probably got some trouble. So this one's hard. I'll give you a hint. The answer to this one, this is a culturally biased question, because the answer is the answer to the ultimate universal question from Douglas Adams' Hitchhiker's Guide to the Galaxy. It's 42, right? And I put this up not to say, look, these things can be hard. It's 42. This is a hard one. What was the first one, which was easy? Subtract. What was the second one, which was easy? Square. What's the third one that's freakishly hard? Well, it's subtract and square. What's 2 minus 1? 1, which is 1 squared. What's 6 minus 2? 4. That's 2 squared. What's 42 minus 6? That's 36, which is 6 squared. And what's 1806 minus 42? 1764. That's 42 squared. That's why you do Kumon math, so you know your squares to 50. So if you know 40, if you happen to know 42 squared, you get it. So the point here is this: innovation, right, comes from combinations of ideas, right? Whether that's true in evolution, that's true in human society as well. I'll talk about that more in a minute. So there's this weird thing that people who study innovation talk about, which is super additivity, which these buzzwords typically bother me, although they're really talking about a sort of combinatorics. What they're really saying, though, is that 1 plus 1 equals 3, because of the fact that if you can subtract and you can square, then you can also subtract and square, right? Or as I explained to my undergrads, when you've got peanut butter and you've got chocolate, you also then get the Reese's, right? So you get this sort of super additivity. Now, people who study technology in a serious way actually talk about things more important than the Reese's, which my undergraduates will say, what? More important than Reese's peanut butter? So if you look at the combustion engine, for example, and scholars differ on this, but most people argue that the parts of the combustion engine were all on the shop floor between 10 and 23 years prior to the engine actually being put together, right? So all the parts were there. It wasn't like everybody was sitting around saying, if we can only get the fuel injector, we can have an engine, right? All the parts were there. The bicycle is another example, right? Originally, we had bikes consist of these things that looked like real bikes with no pedals, and you could sort of push them. So they're really good at going downhill, but not so good at going uphill. Then they started making those bikes with bigger and bigger wheels, right? And there was, I think here, a 15-year gap between sort of the big wheel bikes before, but this is called the safety bike, where somebody said, let's put a chain on those bikes. It wasn't like the chain had not been thought of at that point, right? It's just they didn't think of putting it on the bike. At the level of science, sort of big science, I was at Boeing, I guess it was like a year ago, and they were just like so happy because the government had brought this big grant for doing theoretical research on the energy grid. And someone at Boeing said, hey, you know what's really interesting? What is the energy grid? The energy grid is a network with electricity. Boeing has something like 15,000 electrical engineers or something on staff. And they also have all sorts of people who study networks, right? Because airlines fly over networks. So they realized even though they don't do anything with power, they're a really good theoretical power company, right? So anything you'd want to do sort of mathematically or theoretically about the robustness of the power grid, they were like well primed to do it. And so they actually won a large government grant just by sort of combining 2 of their functionalities. So they're not going to they're not going to start producing power at Boeing anytime soon. And I wanted to say, thank goodness, because it'd be like 40 minutes late, right? But the thing is, they could do it at the theoretical level. And just like sort of one classic example to drive it home, right? The poached egg toaster, which didn't come out till 2002. I mean, we had the idea of the poached egg and we had the idea of toast for a long time. The British had it at least since the 19th century, I think. It took a long time for that. Okay, so how does this play out in reality? So, and here's actually what got me interested in this. When I was working at Caltech as an economist, I got interested in sort of how does the problem-solving economy work? How does the world work in which instead of people, like when I was teaching intro economics, I was teaching stories about people welding ships. And I was teaching this to undergraduates who were going to go do stuff like, their goal would be to come work at a place like Berkeley Labs, right? And they weren't going to be welding things, except for maybe occasionally welding things. So what I did is I created some simple models that work as follows. There's problems out there that people are trying to solve, mathematical problems, and individuals have mathematical representations for those problems, which I'm going to call perspectives. Right? They could be polar coordinates, they could be Cartesian coordinates, they could be some other representational system. And then they had heuristics that they used. And so I'd create these problems and create these agents, and I could rank these agents by their performance on a specific problem. I could say sort of how good are you on this problem, or how good are you across all problems. Now all these agents are going to be pretty smart. Now, to just see how this world worked, I started doing some just, I think what any natural sort of scientific inquiry does, you start doing some baseline experiments just to see sort of, okay, how do these parts fit together? So one of them I did is I wanted to ask, what's the benefit from hiring the best people? So I took one group that consisted of the 20 best people, and another group that consisted of just 20 random people. And to put this in sort of the IQ sense, I've got one group that's sort of this alpha group of all people who are sort of high IQ relative to this problem. So these are people who did well on this problem. And here's a group where some people did well on the problem and some people did not so well on the problem. And then I ask, what happens when you have this team work as a group and this team work as a group? How do they work as a group? So basically, we did it in a simple way. This person took the problem, went until she got stuck. Passed it to this person. If he could make an improvement, he did. If not, passed it to this person. Keep looping through until no one can find an improvement. Now, these aren't he's and she's. These are mathematical objects, but I'm an economist, so I can anthropomorphize mathematical things into people. Okay, so the expectation was clearly the alpha group would do better. The question is, how much better? Well, the interesting thing is, that's not what happened, which is why I'm here, is the diverse group did better. And I couldn't figure out why it was happening, and so I brought in Leo Hurwicz, who is one of my advisors. He had a student, Lou Hong, and Leo once said, I'm going to give you some really good advice, and that is this: co-author with people smarter than you. I'd like you to meet my student, Lou. And so, there's a reason Leo won the Nobel Prize, right? That's it. So I called Lou, and I couldn't solve this, and Lou and I basically then collectively figured this out. And here's what's going on. If you think of people in terms of their, not IQs, but in terms of their tools, the people who do best on the problem alone tend to have similar tools. If I take a more diverse group, some of them have those tools that allow them to do well on their own. And some of them, like I'm from Michigan, so I can trash Illinois at will. This Illinois person has tools that may be useful, but they're not that useful on their own. So how does this work? What do I mean by this? So here's a very specific example. So if you go to like the IMF or the World Bank and you think, okay, these people are trying to manage the world's money supplies, what are the tools? If I wanted to hire a person to manage the world's money supply, what tool would I want? I'd probably want, a PhD in economics. I probably want really good knowledge of statistics. So economics might be A, statistics might be B. C would be I'd want someone who's really good at looking at large data sets quickly and making sense of them. D might be knowledge of the world's banking system, just detailed knowledge of how banks actually function, right? And E might be some understanding of basic political economy. And if you go to the World Bank, what you meet is you meet 600 people who all have those skills, or 2 or 3 of those skills, subsets of those skills. And they do okay, right? They've had some good years and some bad years. Who's IL? So IL is, might be my friend Lada Adamic, who was an undergrad at Caltech and then got her PhD at Stanford in theoretical physics and now is in complex systems at Michigan, who studies networks, robustness of networks, right? So how do you construct a robust network? Now, would I want Lada running the world's money supply? No, because she's a physicist, right? So factors of 10 would be close for her, right? So no way. But would I want to replace one of the 600 economists, all with the same training, with one person who knows something about networks and network failure? Absolutely, right? And so the point is pulling one of these people out and adding her in is going to improve things. By the way, Lada's still mad at me because of this talk. She was hired by the FDIC to do some work at very low pay, but for the good of her country, and your country. Now, unlike the diversity prediction, so the diversity prediction theorem basically says, here's just a simple algebraic relationship between how predictive models aggregate, right? It's sort of 1 part averageability, 1 part diversity. In the case of problem solving, it's a little more complicated. So here we're saying 2 heads are better than 1, and I showed you sort of an example of when that's true. And so the paper that I did with Lou, we had to write down sort of conditions. What are the mathematical conditions that have to be satisfied? Because there's this opposite proverb that says, too many cooks spoil the broth. So we know it's not always true that 2 heads are better than 1. So what has to be true? So basically what has to be true is this. The first condition is what we call the calculus condition. It literally means that we assume people know how to do calculus. So think about it. Somebody's got a representation of the problem, right? And so think of that as just being on this axis. And then there's a function given that representation. And they're trying to find the highest point. If you know calculus, you can take derivatives. So you can find the maxes, the local maxes. So what the calculus condition is basically saying is you can find the set of local maxes given your representation. So it literally is assuming calculus. It's not some sort of buzzword. The second one is the diversity condition. You've got to be choosing from a diverse set. If you're choosing from a set of people who all have the same perspective and the same sets of heuristics, you might as well take the best ones. So if you're only recruiting from one graduate school, from one undergraduate institution, you might as well take the best students who went through that program, right? And the third condition is the problem's got to be hard. If the problem isn't hard, then individuals can solve it and both teams score equally well, right? So if you've got a hard problem and you can draw from a diverse set and those people in that set are all pretty smart, then diversity is typically going to win, right? So these are made more formal in the paper, but that's sort of how it plays out. Now, why is it then the case that when do too many cooks spoil the broth? Well, the thing is about cooking, nobody says too many chefs spoil the menu, right? Because menus are actually developed by lots of chefs. It's because cooking is irreversible. And so if you make a mistake, so you have to have a common narrative. If you make a mistake, right, if you don't follow the plan, you can't undo it. So if I'm making, the example I give is I'm making cucumber soup, and my wife thinks that I'm making green chili enchiladas, and she thinks I don't make them hot enough, right? She just sees this green stuff on the stove. So she jumps more jalapeno in there, and I'm making cucumber soup. I can't like reach in the drawer yet anyway and grab the anti-jalapeno sauce, right, and dump it in. And so if you have, and so the same is sort of like writing a novel is typically done better by one person than by a team of people, right? Because you've got this narrative thread, this single narrative thread, right, that you want to have maintained. So nobody says too many engineers spoil the bridge or too many carpenters spoil the house because you can pound the board back out, right? But we do say too many cooks spoil the broth. So let me give one deep science example of this that I think sort of shows how this plays out in scientific communities. So this is a graphical representation of the PageRank algorithm, which Google uses to rank, when you do a search, the order in which things comes out. Now, the way PageRank works in sort of its simplest form is this. You can think of each site as a balloon, and anytime somebody links to you, you just get a puff of air into your balloon, right? And so the more puffs of air, the more links, the more puffs of air, the bigger your balloon. And what this gives you then is sort of an importance of each link in this node. Look, Mercedes Pasquale, who's one of my colleagues at Michigan, and Stefano Valsina at the University of Chicago, there's a question that ecologists have thought about a long time, which is how important are species in an ecosystem, right? And there's lots of different measures for how important species are in an ecosystem. And Mercedes and Stefano decided, hey, let's just use the PageRank algorithm to rank how important species are and see how that works. And it turns out it's sort of now best to date practice, right? It's better than anything else that's out there, which is really cool. So you're taking this idea from computer science, right, and applying it to ecosystems. This sort of thing only happens if people like Stefano, if Mercedes basically grabs Stefano by the ear and makes him come and sit in interesting complex systems courses where he learns about PageRank algorithms. Okay. So that's problem solving and prediction. Let me just end quickly by talking a little bit about collaboration. There is this sense in science, and we read the books that I talked about this a little bit before, that innovation comes from somebody having this breakthrough idea. But it's actually been studied in great detail by scientists of technology. Eric Maskin, a recent Nobel laureate in economics, wrote a piece recently saying that if you look at innovations, it's very rarely this, right? It's more like this sort of incremental, somebody adding a little thing to something that's going on or something combining things. So most innovation is incremental. Kevin Dunbar, who'd be a good person for people to have out, has actually sat in laboratories and watched, they're mostly biologists, I believe, and biophysicists, and just watched the lab. He sat there like literally for years and just watched what's going on and asked and sort of coded where did the ideas come from. And what he finds is that it's almost never the case that it comes from sitting in their room where somebody walks out of the room going, I've got it, right? Instead, what happens is when in the journal clubs or when somebody's sort of laying something out on the board, people start getting germs of ideas, or somebody thinks of something new and somebody goes, well, let's go check that. And then somebody goes to the office and they come out of the office saying, oh my gosh, that idea worked. So what happens alone in the office is checking really the ideas that get generated through a process that some people use fancy words like bricolage and stuff like that. But it's really just sort of interactions between diverse minds struggling over a problem. One of the real challenges, I think, in a university, in corporations, and anything else, is that there's a lot of siloization going on, right? And so when we think about collaboration, we often have good collaboration within our silos, right? But we don't have necessarily great collaboration between the silos. Now the value, one thing, and hopefully this has been clear in the talk, so I'm not somebody who sits down and says diversity is always good, we want as much diversity as possible. I think in any given domain there's going to be sort of a right amount and a right type of diversity. And one of the things is the challenge is figuring out how do we get that and what types do we need. So what weird type of people should the World Bank be hiring? I'm not saying, hey, bring in some skateboarders. Tony Hawk's a great skateboarder. Let's have him manage the world money supply. But I am saying let's bring in network theorists, right? The value of collaboration really is task dependent. So if it's the old economy and you're digging holes, look, there's no diversity bonus there. The only value from diversity, but it's a big one, is that you're drawing from a larger pool. Right? If I'm hiring people to dig holes, I shouldn't just say I'm only hiring white men to dig holes. I should say, look, I'll hire anybody that wants to dig holes. I can hire the best person. So you get a much bigger pool, that's true. But there's no sort of diversity bump. Now, there is a bump. I love this picture. There is a bump, though, something that people sometimes call boosting. It's not the same sort of boosting that we got from the Ensemble learning stuff. But Christopher Alexander, who used to be here at Berkeley, who studies architecture, talks about when you build a house, there's 10,000 decisions. Right? Of those 10,000 decisions, 9,980 are pretty straightforward, like pound nail into board. Right? But there's a couple hundred of them, though, that really matter, where all the value added is. So when you think about a task, it could be that it seems like the collaborative parts of that task are very small, that 98% of what you do is individualistic, but it could be that 2% is where all the added value is. So I was giving a talk at what's called a white shoe law firm in DC. I still don't know what that means because nobody was wearing white shoes. They described themselves as a white shoe firm. I was like, well, this is going to be cool. Maybe I should buy some white shoes, but nobody had them on. And so I got right about to this point in a different set of talk. I was just talking about the value of diversity, and one of the partners says, well, you know, this is great, Scott, but it turns out we don't need diversity because we dig holes here. You know, we just have these associates go to their offices and they dig holes. And so being an economist, I said, how much do you guys pay for rent for these offices? Because I could see the White House, right, from the window. And they're like, a lot. And I'm like, why aren't these people in Reno then? Right? If they're digging holes, why are you paying this much for them in the offices? And then one of the juniors was emboldened enough to say, actually, yeah, 98% of what we do is digging holes, but when we get to the hard parts, we go ask other associates or we go ask, right, the senior people, and we get this boost up to the counter. Right? And so even if a small percentage of what you do doesn't appear to be digging holes, it could be that most of your value comes, right, from the non-digging holes. And then there are other things like these ant bridges, right, that are just clearly all the benefit, right, comes from collaboration. Now, just to sort of put a bow on this, there's been a bunch of books written recently on sort of the amazing power of the internet to sort of get diverse minds together to collaborate and solve problems in interesting ways, right? So things like, I mean, Jim Sturkey is the wisdom of crowds, but people talk about things like the Gold Corp Challenge, where these machine learning people found literally $9 billion worth of gold at this mine in Canada, that sort of thing. What's interesting, though, about these books is you get something that I like to call the paradox of the oracles. And this is, I think, an important point when you think about sort of the ability to bring people in and the ability to collaborate in a scientific environment. By an oracle, thinking back to Delphi, that's some sort of device or some sort of way where you can go and immediately know whether the answer is better or not. So think of the Netflix prize, right? If you had a different model, you could just press a button and it would say 8.2%, 8.7%. So let me explain this in the context of cars. If you go to Ford or GM, they have these really cool machines where you can design the outside of the car and then press a button. It'll tell you the effect on aerodynamics. Exactly, it's an oracle. So they could let anybody they want design cars, and you can just submit them, and they can just press the button and say, hey, wow, yours is aerodynamically better. Right? So because they've got an oracle, they can have a huge tent, and they can be incredibly diverse on those sorts of problems. Dashboard designs, totally different story. If they have 3,000 dashboard designs, they have no way of adjudicating between them. Right? I mean, they joke, they say they bring in people from the coast who have little patches here in black shirts and talk about how the dashboards feel. But that's the closest thing they've got to an oracle, right? So if you look at other examples in these books, here's the MATLAB programming competition where people can submit computer code. Each one of those dots is computer code. Again, you've got this nice oracle. You can tell how good those things are. So one thing that corporations say, you should think, well, if this is true, corporations should leverage this, and they do. So one thing that like a company like Genentech does is they basically have a rule not strictly, but in their performance evaluations for some of their managers, they have, what is the most important, difficult decision you had to make during the year, right? And then below that is, who from outside your silo did you invite to make that decision? So they basically force on managers, when a problem is hard and important, right, bring in people from the outside. If you go work at Intel, during your orientation, they teach you how to, like, basically stand up for yourself, right? And how to, you know, basically create what they call constructive friction. The reason they do this is groupthink is a huge problem, right? And this is especially true, I think, within the academy, right? And groupthink, it's like sociologists have studied this for a long time. Social psychologists have studied this for a long time. This is like if you mention soft drinks, right? There's the soda region, which is at the California and New York. There's the pop region, where I'm from in Michigan. And then there's the Coke region down here, where I was in this strange culture called Atlanta, where I actually had an orange Coke the other day. That's just orange pop. But and I said, can I have a Coke? They said, do you like orange, Dr. Pepper, or Sprite? I said, I'll have an orange. I thought I was going to get an orange Coke, but no, I didn't. This plays out in, I'm joking, but if you drive from Colorado to Nebraska, the probability of ADHD goes up by a factor of 4. There's something called the Dartmouth Atlas of medical records that does all sorts of diseases by state like this. You're thinking, what the heck is going on? What's going on is all these doctors all talk to one another, right, and all think about things in the same way. So it's with tonsillectomies. There's some states where your tonsils come out with really high probability. There's other states where they don't, right? Because people tended to get trained at the state hospital, and depending on who the person who trained them was, and you just get all that. And it's very hard to go against what other people are thinking. So you might think science wins the day. The soda pop thing is sort of funny. Well, this sort of goes the other way. Just to give one sort of other case sheet is sort of in action. Here's that diversity prediction theorem again. Here's leverage ratios of some Wall Street firms. And you'll notice that you have, I'm trying to think, do I have the right? Yeah, okay, no, this is right, because Goldman Sachs is the only one that didn't sort of leverage their way up. So you have all these banks sort of letting the leverage ratios are sort of going up a little bit. 2004, they start creeping up. The blue bank, I can't remember what it is. I thought it was Merrill Lynch. That's right, it's Merrill Lynch. They're losing clients. They basically say, look, everybody else is doing it, so they leverage theirs up just in time to have the whole system collapse, right? So rather than have a different model, they cave in to have other people's models. There's a lot of work, though, and I should mention this will be my last 2 slides, on how people feel about diverse groups. And here's a really funny thing. If you're in a group of people who look like you and think like you and act like you, it tends to be more fun. And if you're in a group of people who don't look like you and don't think like you and don't act like you, or there's a whole bunch of it, it tends to be harder. That's why when you go visit a foreign country, you're just tired all the time, right? So to put this through the paces, Catherine Phillips, a friend of mine at Northwestern, said, hey, here's a fun thing we can do. Is we know in predictive tasks that diverse groups should do better, right? Because they're going to have different categories, so they should predict better. So here's a homogeneous group and a diverse group on a predictive task. So this is shooting fish in a barrel. The diverse group will do better, right? And they did. But then they said to people, hey, how good do you think the group did? And the homogeneous group said, I think we did great. And the diverse group said, I think we didn't do very well. And then if you ask people, confidence as well, you get the same sort of phenomena. So here's a funny thing, and I write about this in my book a little bit. If you go to a meeting and everybody agrees, it's probably bad, right? There's only 2 possibilities. Either you didn't need the meeting because it was an easy decision, or there was no diversity in the room and you probably just made a bad decision, right? Or you, with higher probability, made a bad decision. If you go to a meeting and there's a lot of sort of constructive disagreement and you didn't win, right? They probably made a better decision, right? So if you go to a meeting and it wasn't very much fun, that's good. In a way, right? That's what Intel tries to teach people in orientation. But it's still the case. I come home sometimes, I'll be honest, mad as hell. And my wife will say, oh, you should read this on page 354 of your book. You should be really happy, right? And so when I think about Pasteur, let me go back to sort of one of the great scientists. So, Pasteur basically said, like, chance favors the prepared mind. With the idea being that innovation breakthroughs come from someone who's, and it's true, from someone who's digging deep, who's in their pond and really thinking about it long and hard, right? And that's absolutely true. Any survey of innovation says they come from people who thought, really hard about something for a long time and have generated lots and lots and lots of ideas. It turns out that great innovators aren't necessarily have better ideas, they just have more ideas. John Seely Brown, who ran Xerox PARC for a long time, would argue that now, because of new technologies, because we can connect with more people and everything else, instead of thinking about the prepared mind, we really want to think about the prepared community of minds, right? We want to think about all the different people that we can bring together who think about things in different ways, and that's really going to ramp up our ability to sort of make innovations. All right, thank you very, very much. And I apologize, I've gone over by like 2 minutes, so if you have to leave, feel free to leave, and I apologize for that. And if you have questions, I'm happy to take some questions. But we have a mic.
A couple of questions.
Yeah.
If some people can say, please, go ahead.
So I want to go back to your example of the aerodynamics versus the dashboard.
Yeah.
So if you're in practice in a meeting and you're trying to incorporate diverse ideas, it sounds like the more successful ones either combined all the ideas or had an oracle to decide what the better model was.
Right.
What if you don't have either of those? Like in the dashboard, you can't combine, and you're just trying to decide which one's better.
Right, so a question I sometimes get is like, how big should our group be? And so one thing is, the sort of simple answer is, to the extent there's an oracleness, to the extent it's going to be easy to agree if an idea is better than another idea, you can be sort of more diverse and larger. So one thing is that sometimes, if there's no oracle at all, some books on sort of how to run these meetings say that you should have 2 meetings. One where you generate ideas, then everybody has all the ideas and they go back and think about them, and then you use sort of the idea behind the sort of diversity prediction theorem. You sort of filter you have a whole bunch of people look at them and have people try and you can use people to become, you can use a diverse crowd to be the oracle. It gets more costly, right? So if there's not an oracle, the cost of diversity just become higher, right? And so if I think about this like an economist, I think, okay, where those cost and benefit curves hit, the extent to which you get an oracle is going to determine it. That's why for things like deciding tenure, it would be better to have, 80 faculty members sort of, all read it deeply. But the thing is, there's no clear oracle, and it would just be a mess, right? And so therefore, you end up having smaller groups so you can really sort of work through things. But companies are learning very quickly at things like, Northwest Airlines, before they got bought out by Delta, when the gas prices got really high, they thought saving fuel cost is probably an oracle-like question. If somebody gives us an idea, we can figure out whether that's going to save fuel cost. And so they sort of let anybody have any ideas. And the people who cleaned the planes had the best ideas. Because a lot of their ideas were how to get, we're putting the same amount of ice on every plane. We don't need very much ice on short trips, right? And that nobody uses these really heavy, we got all these magazines or these heavy, so getting weight off the plane, there was an oracle, and that worked. So in computer science, one of the things I talk about a lot in the open source community is decomposing problems into sub-problems which have oracles. So maybe the entire thing, maybe the entire dashboard doesn't have an oracle, but maybe parts of the dashboard have oracles, and then you can sort of open those up.
This being LBL, it's an invariable rule that somebody has to tell the speaker the things they got wrong.
Yeah, great.
So, one of them
good, otherwise
is,
I don't learn anything,
You said something, cooking, I agree, is irreversible.
Yeah.
But writing is not irreversible.
Right.
Metaphorically, it's irreversible,
Yeah.
like we want a narrative, but you just hit undo. You can undo what you've written.
Right, that's right.
So for whatever reason, I wouldn't be interested in reading a team-written book. It's not because writing isn't irreversible.
It is. Well, so here's the thing that's intriguing about this, and I've been puzzling on this, and I talked to some people who do screenwriting a little bit. So there's a sense in which there's a narrative that's in your head that hasn't fully been played out. So like when J.K. Rowling was writing the Harry Potter thing, supposedly she had the whole 6-volume thing planned out, schematically, and then wrote it. Well, the thing is, so that in some sense the roadmap has already been driven, so you can't sort of hand that off to somebody else unless they fully knew the roadmap. But yet, if you look at the writing of movies, where the stakes are much, much larger, right? Because how many novels are written a year? Hundreds of thousands, probably, right? But not that many big-time movies. Those things are all written by teams now. They figured out how to do it. And there's people who specialize in writing drunken slob, or catty mother-in-law or something. Right? So there's people who literally are specialists in writing dialogue for particular types of people. And so some of these movies will have 17, 18, 20 writers. So movies and plays clearly can be written by teams, but novels, and so it's a question, have we just not figured out how to do it, or is it because, But my guess is that with a novel, you probably could, like if you took a decent novel, one that had a lot of dialogue in it, and you gave it to Hollywood screenwriters who worked on dialogue, they could probably make it better.
Right. Maybe they wouldn't sell twice as many, so it wouldn't be worth having two.
It wouldn't be
people.
worth it. Yeah.
Okay, so the writing analogy was one thing. The other was, sorry.
That's a good point. No, it's just great.
Page rank. I think as you described it, I think I'm sure you know the right answer to this, but as you described it, it's just like the more links, the bigger the bigger the puff. But it's where those links are coming from, too.
Right, no, that's right.
Coming from
So, right, I mean, formally, like if you link to someone who's got a lot of air, then you get more air. Right,
And the third one is actually a good thing. I'm going to agree with you. I actually happen to have a friend who works at the World Bank who is not an economist. He said he's the only one who's at his level. He has maybe 300 people or so below. I mean, he's pretty high up. He's the only one who doesn't have an economics degree, and he was, at least, I don't know if he still is, but he was sort of the golden boy for a while after the crash, because he'd been saying for the previous year, this commodities price thing, it looks like a bubble to me. And everyone's like, no, it's because China's getting rich and they all want to eat meat, so they're buying all the soybeans. Everyone's like, well, yeah, maybe, but it just sort of looks like a bubble. So, anyway.
I think they're learning. I mean, but it's a really hard thing to do, because you just think, why would you bring in some social psychologist or something, right? When they're not as good as, but the network thing is, I think, the thing that opened the door, though, for some, because they just realized when they looked at, when Bear Stearns failed, as far as, you read the books anyway, I don't think they had a clue. And so they basically went to JP Morgan and said, please bail them out because we don't want the financial system to fall apart. When Lehman Brothers failed, if you look at this thing called the Global Financial Stability Report, and they have these network models of like how connected different firms are, and you see AIG is like in the center of this graph. So like if they fell, it would have fallen, and Lehman Brothers, it looks like Barbados or something. I mean, it's just like way out in, and you just look at those graphs and you're just like, Lehman Brothers is gone, right? And Bear Stearns actually probably should have been gone as well, but they just they hadn't done network-based models of failure. And they actually had two different ones, one based on deposits and one based on stock price correlations. And both of them placed Lehman Brothers, off in the hinterlands, and so they just let them go.
So one more question,
okay.
and then we'll close.
Scott, thanks. Very, very nice talk. I have a question about, you have three areas, and you focus a lot about sort of solving a problem. So you have solving the problem and diversity. Then you have preparation, right? That's the other one. You don't want to have people who are totally not prepared to address the problem. And then you have basically defining the problem, how hard, the problem has to be hard. I think a lot about that third one, and how that third one often leads to defining what type of team you're looking for, and how do these ideas and principles of diversity, how do they infiltrate into defining the problem, and how well do organizations do in not just finding diverse perspective to solve the problem, but also to define it, because we tend not to have, I think defining the problem often is more challenging even to really articulate it properly.
I absolutely agree with you. I think that I think organizations differ, broad. I don't want to say this. I think there's big differences in how well organizations sort of recognize what are the appropriate dimensions to a problem, right? I mean, a lot of corporations, for good reason, and organizations think about their core competencies. And so even if they, like I was reading a book recently where someone said, look, if Novartis figured out a great new accounting system tomorrow, they'd just spin it off. They wouldn't do it in-house because they know that's not their core competency, which they'd just sell the ideas. So there's this tension within firms where they sometimes don't look at dimensions because they say that's outside the thing we do. But one of the things I think that a lot of firms are learning now, though, is that scientists are developing so many interesting ways of looking at the world and so many new techniques that they're sort of expanding how they think about things. So let's go back to the Netflix prize. Increasingly, data on individuals, like sort of marketing data, is showing that content doesn't matter as much as other. I was just reading this stuff this morning because this guy at Yahoo was telling me about it. It's sort of fascinating that content doesn't matter as much as you'd think. So you think, like, if you want to know how many people are going to buy this bag of, this type of chips, you think it depends on the calories and those sort of things. It doesn't. Just the sort of signals you get from the market, like how many other people have bought it, time series sort of analysis works better than actually looking at attributes. And so firms are learning, okay, we should hire people who know nothing about what we do that are just good at mining data, right? So there's been a big increase in sort of just data miners being hired by corporate America. because people think that they can find things that couldn't be found before. But I don't think I think one of the hard things within academic departments, and I was at Iowa State last year, there's a question of how do you within a department, hire someone that's not very, or how do you within a university hire people who aren't sort of really mainstreamed, right? Because the academy is really siloed, right? So how do you bring someone in and have them have any chance of getting tenure unless they sort of are really cookie cutter? But yet if you think there's big benefits to having someone who's trained in a different way, you'd like to bring that person in. So I think that, this is one of the things that really is, in the NSF with their IGERT grants and stuff like that, this has been, I think this was their sort of defining vision of those things, is that some of it creating these interdisciplinary graduate programs, you might be able to get that. And the idea was that by putting that cash out there, that would then create incentives for you to think about what are the dimensions, what are the other scholarly disciplines that might really help me, and then to give you money to train graduate students to do it. But I think that's, this problem of what the problems are is a really hard thing.
And we are a Berkeley lab, and
Right.
we have that kind of multidisciplinary approach to solving problems. So
Right.
thank you everyone for
Thanks.
coming, and thank you, Scott.
Yeah.